There's an earth leak through you, but that's not a fault. It's not. So how do we tell the difference between someone on the live part and a load that is faulty? Well, put that aside, that question now. So up until 2008, we protected people against live parts with barriers, with enclosures, with containment, and that was good enough. But in 2008, people were still taking covers off and electrocuting themselves. So they said we need another way of protecting things, additional protection. So we had basic protection from the bus bar that protected people from electric shock. If there was a fault in the fixed wiring, we were protected against that by automatic disconnection of supply. Yeah? ADS. Now we need something for idiots. That's me. I've done this so many times. I nearly killed myself at 15. So I'm not saying everyone else is an idiot. People like me, idiots like me, who take covers off things and then electrocute themselves. But how is an overcurrent protective device supposed to work out whether a person's on the end or just the tiny little load? Because if you think of a 6 amp, the smallest MC breaker that we have in this country, in stock, and we can get 3 and 4s, but in stock, the smallest one we use, a 6 amp, I go and attach myself to some live parts of a light. I could take the ceiling rose off and I put my finger on the switch live and then I say, oh, Carware, can you go and turn the light switch on so I get an electric shock? It's not, it's going to, how much is going to go through a 2000 ohm resistor like me? 0.01 amps, okay? Well, my 6 amp MCB, that's fine, you know, have 6 amps. Oh, you only want 0.01 amps? Oh, you only want enough to kill yourself? That's plenty. Oh, I've got plenty more if you want it. That's what it's saying, all right? So it can allow 6 amps and it's not going to switch off. How are we going to disconnect ourselves if we are getting an electric shock? This is what the engineers had to think. How?
They measure it when it comes.
They measure it when it comes back through, is what Lauren said. So if a brown is chucking out 4 amps, but the blue is only getting back 3.5 amps, half an amp's gone missing. Kirchhoff's law, current law. What's Kirchhoff's current law, Mario?
One more time, sorry?
What's Kirchhoff's current law?
Oh, fuck that.
Kirchhoff's current law is current cannot be destroyed. It always goes somewhere.
Oh, that, yeah.
Yeah, so if I'm getting 4 amps out of my brown and I'm only getting 3.5 back, what's happening to half an amp? Right, we've had a switch off.
Cool.
There we go. It could be going to Earth. It's definitely going to Earth because Earth is the conductor back to the power station.
That's what he said on the video as well.
Earth is the conductor back to the power station. We don't have neutrals beyond the transformer. Beyond the transformer at the end of this building, the Earth takes the dirty washing back to the generator. Out through the air, through the transmission lines, come all our lines at 400 volts, apart from each other, 400,000 volts actually. And then the neutral, look what happens to the neutral. The neutral goes to the transformer, the secondary windings of the transformer, and then goes into the ground and back. Right.
Are you recording right now?
Yes, I'm recording.
Right.
Right. Luke, give me one means of basic protection
Basic insulation.
against live parts.
Basic insulation.
What protects us from the bus bar? The live bus bar. Rocco?
Consumer unity.
Yes. Let's see. Louis, can you think of one means of basic protection? Basic insulation. What does basic insulation protect us from, Noah?
Us touching live parts.
Live parts. Yes.
It's been like it's the rubies of the whole shrine.
Yeah, well,
Like,
Right. Talking about now automatic disconnection of supply. Basic protection's pretty basic. Automatic disconnection of supply. How can we create a situation where we have automatic disconnection of supply? Easy enough, right. Healthy circuit, Caleb. Healthy circuit. Automatic disconnection of supply. Money goes through the brown, comes back through the blue, and it's a bit too much. There's nothing wrong with the fixed wiring, but there's a bit too much going through the brown. It heats up a little element in the MCB. MCB automatically disconnects.
melts the wire.
No problem. Think about this though. We've got a fault. The brown cable's come out and it's touching what? Exposed conductive parts, yes. It's touching exposed conductive parts and there's no current going back through the neutral. It's just livened everything up that's metal. 230 volts. We touch it, we form part of the circuit back to earth, don't we? Back to the power station, and current goes through us. Let's go back a section then. The brown cable has touched exposed conductive parts. What? The MCB's not going to trip, is it?
No.
Because no current's flowing.
Yeah.
So there's no overheating, there's no fault current. What do we need therefore, Lauren, in order to operate automatic disconnection of supply for a fault? We've got no means back to the neutral.
Turn the breaker off.
Yeah, you could go and turn it off, but how? Suppose you're on holiday and it's happened and you didn't know.
Well, you're on holiday anyways. You can't do anything.
Yeah, so it's not very. If there's a fault, can you just turn it off? That isn't ADOS. That isn't
Make
because it's
sure you earth.
because it's metal automatic, is it? It's metal automatic.
Yeah, make sure you earth every metal bit that you
There we go.
before.
All right. Yes. Right. Here we go. He's right. If you've got a fault, that is a brown touching exposed conductive path. You've got to provide You've got to provide a path back to earth, a big path, a big path that's better than 2,000 ohms of me doing it. So it prefers to go down that way. What's that called? What do we call that? Oh, I'm ask you any questions. I'm really sorry. What do we call that?
earthing or bonding.
Yes, earthing. The circuit protective conductor. Is the circuit protective conductor live during normal operation?
Yeah.
No, it isn't. Yes, you can, Hameen.
You're swearing off, bro.
I've got your name right, haven't I? Yeah, good. Sorry about Easter. I haven't seen you for so long. I'm getting so overexcited.
I thought you was John for a second.
Okay, so we've got basic protection, protecting us from what? Live parts. We've got ADOS, automatic disconnection of supply, protecting us from overload and from fault current. And fault current is only protected from us because we've got a path back to earth. Now that path to operate 0.4 seconds by electromagnets needs a lot of current. The last part of this little talk is about overcurrent protective devices.